Hello everyone. We're mostly going to be working with cosine law today, but here's a quick recap of sine and cosine law because you may need to know when it's best to use one or the other. Unlike Pythagoras and regular SOHCAHTOA, we can apply sine and cosine law to non-right angle triangles as well, so they're both pretty versatile in comparison. With sine law, all we need is one full set of a side angle pair, 2 out of 2, and 1 out of 2 in another. If you want to determine a missing angle, you may find this form convenient. You can also use the flipped version if you want to determine a missing side. These two equations are totally equivalent though, so you can use either one as long as your algebra skills are sharp. With cosine law, we can find a side opposite a known angle as long as we know the neighboring side lengths with this form. Or if you know all three side lengths, you can figure out any angle you like with this alternative form obtained algebraically from the one above. Once you know the labeling convention and your calculator is in degree mode, you can solve acute non-right angle triangles fairly easily with no ambiguity. Now we're going to take a quick scroll through the questions from last class and do a few more cosine law questions. So here's 4b, here's number 5, here's number 6, and we'll jump ahead. So in this question, a ship travels south from port for 2 hours at 35 kilometers per hour. It then changes course and travels 20 degrees west of south for 3 hours at the same speed. How far is it from port after 5 hours? So we need to figure out this distance here. And if we call the interior angle of the turning point t, we'll call this side length t. And that's what we need to figure out. So we might as well call this angle p, and this side p, and this angle b, and this side b. So at the moment we don't know any side lengths for this triangle, but we can figure them out because it travels 35 kilometers per hour for 2 hours on this leg. So in 1 hour it travels 35 kilometers, and in 2 hours it travels twice that, so 70. And similarly we can figure out what p is. It's gone for 3 hours at this speed, so that makes 105 kilometers. Now we need to figure out angle t. And because this angle is supplementary with 20 degrees, we can go 180 minus 20, that will be angle t. So this is 160 degrees. And now we can apply cosine law. So we want to figure out what t is. We have side b and p, and then we subtract 2bp times cosine of angle t. And now we can just plug in what we know. So b is 70, p is 105, subtract 2 times 70 times 105 times cosine of 160. So we proceed with our order of operations. 70 squared is 4900, 105 squared is 11,025, and this last term is negative 13,813. And if we are subtracting a negative, we need to add 13,813. Next we can add everything up, and we get 29,738.48 and some other digits. So that's t squared, and in order for us to figure out what t is, we need to square root both sides of this equation, and we find that t is 172 kilometers. Looking at this question next, on a triangular frame of a bicycle, the distance from the seat to the handlebars is 52 centimeters, the handlebars to the gears is 56 centimeters, and the gears to the seat is 42. We need to figure out what angle S is. And because we know all three side lengths, we can do that. So this would be called side G, this would be called side S, and this would be side H. And now we can write cosine law to solve for angle S. The first two terms squared are the terms other than S, so we would do G and H. And then we subtract S squared and divide by 2GH. And now we just plug in what we know. So G is 52, H is 42, and S is 56. And we divide that by 2 times 52 times 42. The numerator in this expression gives 1332, and the denominator gives 4,368. So if we divide 1332 by 4,368, we get 0.3049 and some other digits, and that's equal to cosine of angle S. If we are to determine angle S, we need to take the inverse cosine of the number on the right, and that gives us an angle of 72.2 degrees. So that's it for me for today. You can do these questions, and I'll see you next time.